This is 4.5, Applied Problems with Rational Expressions. So applied problems are word problems. So essential question, how do you write and solve a rational equation? So you have to write the equation this time, okay? So we're going to start with work problems. With work problems, you have the individual plus the individual equals job complete, or you could have together minus individual equals other individual. I'm going to tell you that this one, I'm going to highlight it. This is the one I use every time because you can solve using this one every time, and it just kind of makes it a little bit easier if you only have one thing to know how to do. Okay, so we're not going to really worry about the other one. You could even, and I will do it right now, cross it out. It is correct. It's not wrong. You can do it. But let's just use one. Why not? Okay? So what this means is it's how much the first person will do of the job plus how much the second person will do of the job, and that equals a total job complete. Okay? So I'm going to write out the equation, how we're going to use it. Okay? So we have the total time, T, divided by the first person, I guess. Okay? We'll call it x1 plus the total time divided by the second person's. Okay? And so when we divide the total time by the first person's amount, which we'll see what that is in a little bit, you get how much the first person does plus how much the second person does. And that needs to equal 1. Okay? Because you have the first set of time plus the second set of time equals 1 complete job. We want it to equal 1 because it's basically, this is a percentage plus another percentage equals 100%. We want the job to be complete, so that's 100%. But remember, we can't use percentages in math work, so we use the decimal version. 1 is the decimal for 100%. So we are completing the entire job. So this right here, I'm going to box it, I'm going to star it. This is the equation you need to know how to fill out, where T is the total time. Usually that's what we're solving for, but not always. X1 is the first person's chunk. T is the same, the total time, divided by X2, which is the second person's chunk, and that always equals 1, which represents 100%, the full job being done. Okay? So, the Pardinis are having an outdoor barbecue next weekend. Their sons are Tony and Frank. If Tony works alone this weekend, it will take him 8 hours to clean up the backyard. If Frank works alone, it will take him 10 hours. How many hours will it take if they work together? Okay, so T is the time together, remember that. And that's what we're looking for. In hours, how many hours will it take them to work together? That's what we're solving for. X1 is the first son. So Tony is the first one they talk about, and he takes 8 hours. So we'll have X1 equal 8. X2, that's the second kid. In this case, it's Frank. He'll take 10 hours. So X2 equals 10. It's a 2. Okay? And so we just have to set up our equation now. T, what we're trying to solve for, over 8 plus T over 10 equals 1. And you might recognize this is what we've been doing. This is solving a rational equation. So we're going to solve it the same. We need to look at the least common denominator. So we have 2 denominators here. And we need the least common denominator between those two. Okay. So what bigger number can I turn both 8 and 10 into? Well, 40. 8 times 5 is 40. 10 times 4 is 40. And so remember, what we do is we take every single thing, the ones that are fractions, oops, I don't know why I put parentheses, and we multiply by that LCD, 40. And when it's a fraction, we put it over 1 just to make things consistent. When it's not a fraction, we leave it as just 40. We're just multiplying everything by 40. With the fractions, we put it over 1 to make it a fraction, so it makes it easy to simplify and all that. All right, so we look, 8 and 40 on the first one simplifies, so I'm left with 5 times t, plus the 10 and the 40 simplify, and so I'm left with 4 times t, and the 1 times 40 is 40. So we combine our like terms. 5t plus 4t is 9t, and then we divide. Okay. So I actually would accept 40 over 9 hours. If that's what you want to leave it as, because you struggle with fractions, as long as you get to this spot, that's full points. But I would say the better answer, because it's more clear, is if you actually divide. Well, okay, so 9 goes into 40 4 times. So over here, I'm just going to divide, long division over here. Goes in 4 times, so I subtract 36 with a remainder of 4. So if we remember what to do with our remainders, we put it over the thing we divide. So it's 4 and 4/9 hours. Okay, that one is a lot more easy to understand. And so notice something. The time, 4 and 4/9 hours, is not quite half of Tony's, because if there were 2 Tonys doing this job at the same time, it would take half the time, which is 4 hours. But Frank isn't as good as Tony. He takes 10 hours, so it's a little more than half the time there. And it's a little less than half the time that 2 Franks would take, which is 5 hours. So it's between half of each value, and it should always be that. So 4 and 4/9 is between 4 and 5, which is half of 8 and half of 10. Okay, because they're a little bit faster than 2 Franks, a little bit slower than 2 Tonys. Okay, so there we have it. And that works for every single type within this category, the work problems. Example number 2, at Baxterville City Firefighting Training Facility, a temporary structure is set on fire. If 2 crews work together, they can put out the fire in 50 minutes. Alone, the lesser experienced crew can put it out in 110 minutes. How long will it take the more experienced crew to put out the fire if they work alone? All right, so this time we have a little bit different. Together is 50 minutes, so that's T. The lesser experienced crew is 110 minutes, so we'll say that's person 1. In this case, crew 1. 110. The one we're looking for is the more experienced crew alone. So we're looking for X2, because that's what we're going to define as the more experienced crew, X2. Okay, so we got to set up our thing. So we get T over X1 plus T over X2 equals 1. So there is X other ways of doing this, but we're just going to solve it the same way. Keep it consistent. You don't have to make it more complicated. So we look at our 2 things. So what is the LCD? Well, in this case, we need 110 for that one, and we need an X2 for that one. Remember, the 2 is just signifying the group. So it's not the first group, it's the second group, the more experienced crew. Okay, so I'm going to multiply everything by that. So the 110 x sub 2 over 1. This one, 110 x sub 2 over 1. And this last one is 110 x sub 2. So the 110 simplify in the first one. So I'm left with 50 times x sub 2 plus the x sub 2 simplify. So I'm left with 50 times 110, which is 5,500, equals 1 times 110 x2. Okay. Then I need to get the x's on the same side, so I'm going to subtract 50x2 from both sides. So I move it over. So I get 5,500 equals 110 minus 50 is 60 x2. And then I just divide. by 60. I'm going to write the x2 first. So this side first. So x2 equals, we need to simplify if we can. So in this case, we can definitely simplify here. 10 goes into both, so that would be a 0 gone. 2 goes into both, so that would simplify this to, let's see, 275. And is 275 divided by 3? Nope. It's not a perfect number, so if you wanted to, you could do this. 275 divided by 3 minutes. But I'm going to, like I said, you can leave it like that, but I'm going to write the answer by actually dividing. Okay, so on the side here, I'm going to do a little long division. 275 divided by 3, first is 9. Bring down the 5, and I get 1. And that's my remainder. So I get 91 and 2/3 minutes. That is how long the more experienced crew would take by themselves. Okay, and let's make sure it makes sense. The less experienced crew should take longer. 110 is definitely longer than 91. Okay, together it should be the shortest of all. 50 is shorter than 91. Okay, so it does indeed make sense. So there we have it. 91 and 2/3 minutes for the more experienced crew, which we defined as x2. All right, so that's the first type of problem. That was the work problems. Okay, now we're going to do the average cost problems. The average cost problems will start with an average cost, but something will happen. Either more people are added or people leave or are removed. Okay, so if the more people are added, the average cost decreases, right? More people makes the cost go down. If people are removed, the average cost will rise. Okay, so I'll highlight this right here. Once again, this is your little thing. There is a key part here though. This is not plus and minus. It is plus or minus. We have to pick one based on what the adjustment should be doing. Is the average cost going up? It's plus the adjustment. Is the average cost going down? It's minus the adjustment. So I'm not going to write out in variables. I'm just going to leave it like this. So this is your other equation, which I'm going to box and star. Okay? So all these problems are going to be like this. So we're going to start with an easy one. It says a small group of students, X, they even define the variable for you, X, are having a study session one night. We don't know how many students are there yet. They realize it's going to be a long night and they order pizza. The order amounts to $24. That's a key thing. That is the total price. Okay. Before the pizza arrives, another student joins the student study group. One more student, so they add one student. With the additional person, the average cost decreases by $2. So we lost $2. How many students were in the original group? Okay. One thing to realize here is they gave us the total amount, $24. They did not give us the average amount originally because we don't know it. So it's the average cost of the original group. All we know is that if we took $24 and divided by X, the number of students we have, that would be the total cost. Okay, now we have our adjustment. It decreased by $2, minus 2, equals the average cost of the new group. Well, we added a student. So my average is 24 divided by X plus 1. We added one more student. So if I took the total amount and divided it among the people evenly, there we have it. Okay, and so then we're going to follow our techniques we've been learning. We look at our denominators. Notice this question is the harder question. X plus 1 is my LCD. X and X plus 1 are my two factors that I have to look at. So I have to multiply everything by that LCD. The fractions I'm going to multiply over 1 just because it makes it a fraction, so I don't have to think about it. And then we simplify. The x's simplify, so 24 times x plus 1 minus 2x times x plus 1 equals, the x plus 1 simplify, 24x. Okay, we got to distribute. So 24 into the first one and negative 2x. Don't forget the negative part, that whole thing into the second one. So I get 24x plus 24 minus 2x squared minus 2x equals 24x. All right? Squared, it's a quadratic. To deal with a quadratic, we need it all on the same side. I want it to be positive, so I'm going to move it over. Notice I'm subtracting 24x. Those two terms are going to go away. But we need to move everything over because it needs to equal 0. But I want it to equal 0 when I have a positive x squared term. So I end up with 0 equals 2x squared plus 2x minus, oops, I don't know why I said 240. It's minus 24. Okay, and then we factor. What kind of factoring do we always look for first? This is key for these word problems. GCF. All of them have a 2, so I'm going to factor out a GCF of 2 first. If you don't do that, you will make life so much harder for yourself. Okay, then we look at our factors of this trinomial inside. So it's x and x, and I'm trying to make a 1, so I'm thinking it's 4 and 3, because 12 and 1 wouldn't work, 6 and 2 wouldn't work, 4 and 3 seems to work. Okay, so I think it's going to be x plus 4, x minus 3. 4 times negative 3 makes negative 12. 4x minus 3x is positive 1x. Checks. Good. Okay. 0 product property. 2 can never equal 0, so I'm not worried about that. But x plus 4 can equal 0, and x minus 3 can equal 0. So I get x equals negative 4 and 3. 2 solutions. Technically, we have to look at our excluded values. Our excluded values are 0 and negative 1. So those wouldn't work. But we also have another excluded value. What does x represent? Number of people. Can I have negative people? No. So we take out the negative. So x equals 3 people. It's how many students were in the original group? 3. How many students were in the new group? Well, we added 1, so it'd be 4. Okay, so we found that 3 people were in the original group. So example number 5, much more difficult problem now. It's not really more difficult in the process, it's more difficult in the numbers. An amusement park gives group discounts. Last month, a certain sized youth group paid a total of $651 for admission tickets. This month, they were told that if 4 more people were in their group, okay, so I should actually be underlining things. So we have X, the number of people in the original group, a total of 651, not the average, the total. They were told that if 4 more people were added, so plus 4 to another people, the group would pay $990, resulting in a $3 discount per ticket. When compared to their prior visit, how many people were in the group which visited the park last month? So that's the original number. Okay. So they're trying to decrease their costs with 4 more people. Notice the costs change. That's what makes this so much more difficult. Where the cost was the same. They ordered 1 pizza, and they split the cost, then 1 more person was added, so they split that same cost. Now they're splitting $651 originally. When they added 4 new people, they are splitting now $990 with a $3 discount per ticket. So we have to go through the other thing. Average cost of the original group. So that'd be 651 divided by X. That was the original group. They split $651. $3 discount. That means it's going down by 3 again. Okay, don't assume it's always going down by 3. Pay attention. These 2 example problems, it was going down. But if it's an increase because someone leaves especially, then it goes up. Equals, they added 4 people. So you have 990 over x plus 4. Okay, so we look. And I have my LCD of x plus 4. Make sure I multiply everything by that. Go through this a little quicker. Here we go. 651 times x plus 4, negative 3x times x plus 4. And this last one is 990x. Okay, so now we got to distribute. Notice the numbers are bigger, so it's not quite as nice. 651 by 4 is 2,604. Distribute this one. Remember, it's the negative 3x, that whole term in. So it's negative 3x squared minus 12x equals 990x. Okay, it doesn't quite work out as nice as last time, but I see I have these two on that side, so I'm going to combine them first. So I get, what is that? 639, I believe. X plus 2604 minus 3x squared equals 990x. Oops, forgot the x in that last one. All right, so I need to add 3x squared. I need to subtract 639x. And I need to subtract 2,604. And so I get 0 equals 3x squared. Subtract these. 990x minus 639x is 351x. I would use a calculator for that. Okay. We always check for a GCF first, which this one actually indeed has. Not easy, but it is a GCF of 3. Okay. So x squared. So I divided these two and I got 117x and 868 when I divided by 3. 351 divided by 3 and 2,604 divided by 3. This last one's negative, by the way. Negative 2,604. Okay. So then I have to factor this. Not very easy to factor. I know it's x and x, so that's nice. I need to make 117. So I start dividing 868 by numbers until I get something close to 117. And it ends up as negative 7 and 124. If you check, negative 7x plus 124x is indeed 117x. So all I did was take 868 on my calculator and I divided by 2. Then I divided by 3. Then I divided by 4 until I got something that was close to 117. Then I checked it. Okay, takes a lot. Okay, so then we set these equal to 0, 0 product property. And I get negative 124, which can't work because you can't have negative people, or 7. So there was 7 people in the original group. There it is. Okay, so then we have to do examples 6 and 7. Given the equation, solve for v. Okay, so I just rewrite my equation. I need to get v by itself. So I'm going to multiply both sides by t to clear the fraction there. So I get t times g equals v squared. And hopefully you know how to get rid of a squared by square rooting. Technically it's supposed to be plus or minus, but it says assume v is positive. So I'm only going to have the positive v. And there it is. Done. Okay, next one, solve for r. Same exact idea. So I'm going to clear the fraction first. So the m's go away. So it's a times m equals 5r plus 1. Okay, so now let's subtract 1 from both sides. So I have a times m minus 1 equals 5r. Then I'm going to divide everything, the big old fraction line on the left side, and I get r equals am minus 1 all over 5. Done. R is by itself. Solved it. And there we have it. So there are going to be some questions like this. We didn't want to give you a whole bunch of word problems, so we kind of combined these two ideas. And that's it. So you make sure you're answering your essential question and summarize in 3 sentences.